In the development of solar photovoltaic energy technologies, there are many solar cells have been fabricated, and these solar cells are mainly classified into first, second, and third generation solar cells. Among these solar cells, dye-sensitized solar cells offer some advanced properties than others, such as transparency, low cost, fissile fabrication process, and sensitive for low intense light. What is dye-sensitized solar cells? A dye-sensitized solar cell with an efficiency of 7.1% was first reported by Regan and Kretzel in 1991. The dye-sensitized solar cells mainly contain 5 parts. First one, a transparent conducting oxide coated glass. A transparent conductive oxide coated glass plate used to collect the photoelectron to transfer the external circuit. In general, fluorine doped tin oxide or indium tin oxide coated glasses are used. Second one, mesophorous metal oxide. The N-type semiconducting metal oxide used as a photoanode, which is deposited on the transparent conductive oxide coated glass. In commonly, titanium dioxide has been widely used as mesophorous metal oxide. And that one is a photosensitizer. Natural or commercial photosensitizer used to harvest the visible light in the solar spectrum. And next one is a electrolyte. An electrolyte is a redox mediator in dye-sensitized solar cells, which transport electron back to the oxidized dye molecules. The final one is a metal electrode. A counter metal electrode in dye-sensitized solar cells is used to regenerating the redox couple. Usually, platinum coated counter electrode is used as counter electrode. Next, we move to the working principle of the dye-sensitized solar cells. When the dye molecule in the device are exposed to the sunlight, they get excited from the highest occupied molecular orbital to lowest unoccupied molecular orbital. Then the excited dye molecule inject the electron into the conduction band of the mesophorous metal oxide. This injected electron diffuse through the mesophorous metal oxide to transparent conductive oxide coated glasses and reach the platinum coated counter electrode through the outer circuit. The I3 minus ion in the redox couple are reduced to I minus by receiving electron from the platinum coated counter electrode. Finally, the oxidized dye molecule are reduced by I minus ions in the redox couple. Now we can go to the demonstration of the fabrication of dye-sensitized solar cells. Good morning to all. Now I am going to demonstrate how to fabricate a dye-sensitized solar cells. First, FTO class clean in sonicator with soap water, deionized water, and finally with ethanol. In FTO classes, one side is conductive side and other side is non-conductive side, which can confirm by the multimeter. When the non-conductive side connected to the multimeter, it does not make a sound, but for conductive side, it makes a sound by the detector. Then the FTO class with conductive side upwards were placed on the substrate. Now I am going to cover the non-required area with the masking tape like this. This is our required area, which is 0.25 centimeters square. In the titanium dioxide paste preparation, first TiO2 was added into mortar, then required amount of deionized water was added and crowned well. After that, acetyl acetone was added into it and again ground well. Finally, the return X content was added and ground until it became a fine paste. This paste was placed on the FTO and coated a film by Dr. Blade method. Then the TiO2 film was allowed to air dry and the masking tapes were removed. Finally, the TiO2 coated FTO glass was sintered at 500 degrees C in the furnace. These films were then dipped in the prepared dye solution and keep it for 12 hours for the sensitization process. After 12 hours, the film were taken out from the dye solution. This is our counter electrode. Here the one side is coated by the platinum. Finally, platinum coated counter electrode are placed on the dye sensitized photoanode and firmly attached by the clips. After that, small amount of iodine electrolyte were added between the two electrodes to complete the device.